finishing this lecture, definitely this is very useful lecture, and you will see so many new technologies which are evolving in the society, where the market is now depending on this new technology platforms, where these technologies are really useful to produce new molecules and to invest new drugs or new drug molecules. That's what I'm going to show you. And I will start a brief introduction. And right now I'm working for RG Life Sciences. Can you move to the next page? So this is just a brief introduction about my education, where I have studied. So starting from my elementary education and undergraduation, graduation, I have studied MSc Organic Chemistry in Sri Venkateswara University in Tirupati during 96-98, and then I have done my PhD in Japan. I got a Japanese government fellowship for doing my PhD. I have done a PhD in pharmaceutical sciences, and then, can you move to the next slide, please? So and then I started my career in Japan itself as a postdoc fellow, and then did my JSPS as well from Kyoto University. And Kyoto University, one of the biggest universities in Japan. Right now it is in second place after Tokyo University. There are so many Nobel laureates from Kyoto University, and I am very happy to be associated with Kyoto University for several years. And then I moved to BOILOGICAL pharmaceutical company, which is a multinational company, where I involved to find a new medicine for neuroscience. We have a medicine in the market right now. It's called aripiprazole, which is antidepressant molecule, and you can also find in the market. And it works for depression. If anybody goes under depression, they can take that medicine and recover. So that's called aripiprazole medicine is available in the market, and I had an opportunity to work and invent that medicine, and I have 2 US patents related to that market, that medicine. And then I joined in RG in 2011, which is a multinational company right now, and right now I am working as a vice president, where 350 scientists are working with me right now, and we are supporting, our main job is to support, to find a new medicine for various diseases like neuroscience, like a depression, schizophrenia, and also cancer drugs, and also several diuretics and cardiovascular diseases. So our main job is to find a new medicine. We know that there are so many medicines available in the market, but still these medicines have so many side effects, and the dosage problem. For example, if we have fever, we are still taking 650 milligram of paracetamol tablet. So our goal is why to take 650 mg. So why can't we take 100 mg and get cured the patients? So that's what our intention as a scientist. We wanted to find the better medicine, the best medicine for the patients using the new technology platforms, and give it to the society where the patients can recover by taking these medicines, and the diseases can be cured easily. So that's what our goal is, to reduce the side effects and find a better medicine which is economically available for poor people, middle class, and everybody. That's our goal, to find a new medicine. So that's the company goal, and we support to various companies across the globe, and there are 650 customers working with us right now across the globe, from US, Europe, Japan, and these countries mainly. And we support mainly various pharmaceutical companies like GSK, Pfizer, Merck, whatever. All the companies we work with us. The main job is finding a new medicine and giving it to the patients. That's what. And so whenever I have time, I go to the various universities and colleges, so to motivate the people, at least particularly the people who wanted to study chemistry. And still many people think that what is the use of chemistry, what is the use of science. And recently, I think now the number of students coming to the university for post-graduation in science division particularly, it's getting reduced. That's why many universities and many colleges, they do keep contacting me at least every 2 months, 3 months. Whenever I have time, I go to one university or college to motivate the people, particularly to study MSc Organic Chemistry or Medicinal Chemistry, what is the benefit of chemistry and what chemistry can do wonders, and particularly finding a new medicine and new tablets and discovering a new medicine. These are all, the basic is science. So the science can do wonders, the scientist can do wonders, and there is proof also that a scientist is far better than a doctor, because if the scientist doesn't find a new medicine, doctor cannot give any medicine. So the scientist role is very, very important in the society in finding a new medicine and giving it to the society. That's where I think there are so many proofs that scientists prove that in finding a better medicine and giving it to the society and play an important role in the society where finding a new medicine, better medicine for the patients. So this is what. So I go to the several universities, and recently there are some universities. I went to Andhra University, and one more college is in Bhimavaram, Vishnu Engineering College, and also Ramachari, myself, we had one lecture, and also I went to Japan for some time, some Japanese universities also to give some lectures. So the intention is that we wanted to motivate the people, and we wanted to educate the people, at least the knowledge, the intellectual property, what I have, just I need to pass it to the next generation, and the next generation people, at least they will learn something, and they will know what is the importance of science, what is the importance of scientists, what scientists can do, what scientists can give to the society. So that's what I think. So particularly the chemistry, medicinal chemistry has a lot of value. So the people who are studying MSc Organic Chemistry, Medicinal Chemistry, and the companies like us, we recruit the people who are having medicinal chemistry, MSc Organic Chemistry background people, and train them and make them a good scientist to find a new medicine, and that's what, and support the various pharmaceutical companies. And that's what I go to the several universities and colleges and encourage people to study chemistry, science, or physics, or maths, whatever it is. So science is always having a lot of value addition in the society. So please pursue MSc post-graduation science subjects. There is a lot of value, a lot of demand going forward, even though we have artificial intelligence and robotics, but still a scientist is must and needed to find a new medicine, to find a new drug, whatever it is. The next slide, please. Can you play this video? So now I will show the video where, till now, the human beings are doing the reactions and producing compounds. For example, the people who have idea about organic chemistry and producing reactions, producing compounds, you can see now how robotics are working to produce compounds in high throughput manner. You can see this video, and just a few minutes video, you can just watch it. So this is called a mini robotic in the synthesis. So in our company, we have robotics like this nowadays. And to do the same work, at least we need 5 scientists for 1 month time, which can do in 1 hour. This robotic can do 1 hour work, and 5 people can do 1 month work. The same work the robotic can do within 1 hour, without any errors. With 0% error, it can do within 1 hour. But the same work, if we wanted to carry out physically, so we need 5 scientists for 1 month time. But there may be some errors, again human errors, with weighing or probably plus or minus or something like that. But robotic can do with it with 100%. So these are all the new technologies coming up with AI based or the new technology platforms, whatever it is, like robotics. So in organic synthesis, particularly in pharmaceutical industry, when we wanted to make a bulk set of compounds or high throughput set of compounds for screening purpose at the initial stage, we use this kind of robotics to make millions of compounds or more than millions of compounds in few months. These robotics are really helpful to make the compounds in milligram scale or microgram scale for initial screening. So that's how these new technology platforms we are using now to make this kind of large set of libraries at high throughput scale. Can you move to this? And next also, we also do catalyst screening using these new technology platforms. I think there are MSc organic chemistry people here. You might be knowing that there are several catalysts in organic synthesis. For example, very famous coupling reaction, Suzuki coupling, when you wanted to make CC bond for new, aromatic molecule. When there are aromatic molecule A and aromatic molecule B, we wanted to connect between 2 molecules and there should be new bond formation, CC bond formation. So this CC bond formation is possible basically using palladium catalyst. That's called a known reaction, Suzuki coupling reaction. So this kind of Suzuki coupling reaction, so when you wanted to do physically 1 by 1, and it takes longer time and we need to wait several times, but in pharmaceutical industry, we cannot wait like that. We need to produce in 1 hour so many compounds, like 50 compounds, 100 compounds or something like that. In 1 day, we need to produce at least X number of compounds like 200, 300. So when you want to produce this many number of compounds, you cannot do physically or normal methods. You need to go high throughput methods or new technology platforms where we use catalyst screening. So we put several catalysts here, like 10 catalysts, 15 catalysts, palladium, palladium DBA3, palladium chloride DBPF, palladium acetate, and like several palladium catalysts, we take it and we screen the catalyst within a couple of hours which catalyst is better for this reaction. Because initially we don't know which catalyst will be useful. So we need to screen the catalyst. So that's why we use these new technology platforms to screen the catalyst in few hours and find the best condition for the reaction, and then we can take that reaction to next level, making gram scale or milligram scale or multigram scale or kilogram scale. That's how we use the new technology platforms nowadays to find the better condition for making new molecule, CC bond forming new molecule between 2 aromatic molecules. That's how, when we wanted to find a new drug, we need to find several new molecules. From the molecules only drugs come. So medicines will come. So that's why initially we need to create a set of molecules, millions of molecules, billions of molecules. So that's why we do all these technology platform reactions like catalyst screening and all, and find the better condition. Can you move next? So these are all equipment, how we do catalyst screening. So you can see the left side, this is called a kit, and we have like a 12 or 10 catalyst kind of kit which is available commercially also, and also we can make inside the company. And this kit will have several catalysts, for example, palladium DBA, palladium acetate, palladium chloride DBA, all which are useful for Suzuki coupling reaction. And then we take this one inside the glove box. Glove box is nothing but which is having a complete, vacuum box, and which is passed through inert gases like nitrogen, argon, because oxygen is not good for cyclic coupling reaction. That's why we create atmosphere where these reactions will be running under inert atmosphere like a nitrogen or argon, and that's called glow box. And we put in the glow box, and you can see the right side micropipette where we load the reactions in micro scale, and these plates are available in 48 or 96 well plate reactions, and we make these reactions a set of reactions quickly, and we can use robotic also, and we prepare that kind of plates, and these plates can be put in the stirrer. It's called a tumbler stirrer, the middle one, and then we stir in the stirrer at room temperature or heating or something like that, and then we check the LCMS for the finding the result, and within couple of hours or something like that, and then we can see which reaction is positive, which reaction is negative, and the positive reactions we can take it to next level. And we can do these reactions using hydrogen gas also. For example, like palladium carbon hydrogenation reactions, when we want to reduce bond to double bond, we use palladium carbon, a Lindlar catalyst organic reaction, you might be knowing that. And that kind of reactions also we can do using this new catalyst and screening method. Next. And this is one example. You can see, for example, aryl halide, aryl bromide, and you take boronic acid or boron pentalate, and the right side we found a new molecule is formed between two aromatic groups, CC bond formation, and then these are the reactions we have done. So you can see the bases, 4 bases we have chosen: potassium carbonate, potassium phosphate, and 2 bases. And right side you can see catalyst for palladium catalyst. So we took 6 catalysts and 2 bases. So 6 multiplied to 12 reactions we can do in one shot and find the better condition, which is positive, which is negative quickly. So these are all the new platforms, new technology platforms where we can do the reactions in parallel, not one by one, but in parallel we can do a set of reaction. This is called, we call this one is one reaction, one pot reaction, but we can find the result very quickly. Next one please. And this is also another example for the similar kind of reaction to screen the catalyst so quickly using 2 bases. Next please. This is Buckwald reaction, and this is also alcohol screening, a different type of reaction. So you can see we take halide and then alcohol and make ether molecule. So using this set of reaction so quickly. Next one please. And this is also another technology we use in the pharmaceutical industry. Library molecules. Library in the sense, so where we keep a set of molecules in one house. If we keep books, it's called books library, and if we keep molecules, it's called molecules library. So we create libraries using this technology platforms. So you can see here microwaves and also parallel synthesizers and automated purification systems. We use these all set of instrumentation to produce libraries. I mean a set of like 1,000 molecules, 2,000 molecules in 1 hour, 2 hour time. So for this one, we use very less human manpower. Probably 1 scientist or 2 scientists will be working, but more or less these all machines will be working to produce these new molecules using these new machines. And also at the bottom you can see we have photoelectric light synthesizers where some of the reactions will be done under photoelectric light. I think you will be studying these photoelectric reactions in MSc second year, where the reactions will be irradiated by photoelectric light, and it is the energy source, and the molecule will be irradiated, and then the new bond can be formed using this kind of photochemistry, and that's where we have photochemical synthesizers also in library facility, and we produce this molecule. So in the library, actually, initial screening and production and purification, these three stages will be there. For purification and all, we use the right side machines. This is called mass-based purification system. Based on the molecule mass, it purifies the molecule and gives the desired molecule to us. And this is the flow chart in library, how we produce molecules and what are the stages. So initially we plan what are the molecules series using this technology platform. These are all the machinery. I already showed it to you, and reaction kit and micropipette and liquid handling dispensers like robotics. It makes the reaction vessels and everything by automatically, and weighing machines, automatic weighing machines, and glow boxes and everything. These are all the machinery we use in the library facility. This is the we call liquid handling dispenser. As I showed in the video, this also makes the same job that creates the wires automatically when we set in the computer that this is the weight for each reaction. It makes the reaction vessels automatically using this liquid handling system. And these are all instruments we use in the panel library screening, like aluminum blocks which are having 24, 48 vessels, and also that kind of plates, metal plates for heating and all. And for photoelectric reactions, we use these all photoelectric lamps at various wavelength, photoelectricity, and also microwave synthesizers for making the reactions under microwave irradiation. These are also photochemical reactions under various levels. We use these smaller wires, bigger wires for photochemical reaction, and using the screening method, which condition is better for photochemical reactions. So these are also instruments for library production, like Radley synthesizers to produce molecules, a set of molecules so quickly using this machinery. Yeah, next one please. And this is all purifications in the libraries. We used mainly mass-based purification system on the left side, and this will purify the molecules. For identification and all, we use LCMS and everything for identifying the reaction success rate, whether it is molecule is formed or not formed, and everything. These are all drying stage and post-production. So we use GenVac to dry up the reaction mixtures and everything when we produce the libraries. So I will show you some case studies for libraries. What are the libraries we produce? The example of reactions. Yeah, next slide please. So you can see this is one reaction. So where we have amine and ester, aromatic molecule, and we wanted to link this one with another heterocycle which is having bromide, and this reaction we call as a Buchwald reaction. So for Buchwald reaction, we don't know which condition is better because these are all new molecules and we are synthesizing in the lab, and to find out this one, and these are all, so we have done 48 reactions so quickly using these several catalysts and also bases. These are all we plan it and set it in the computer, and the machine will done automatically so quickly. And you can see two reactions, the green color, like a C5 and C9. Initially it is 29%, 25% conversion we have seen, and then we take it to next level, these positive reactions, and produce in bigger scale. This is how we do this a set of reactions so quickly using these technology platforms. And this is also another Buchwald-Suzuki amide coupling reaction. So total 97 scaffolds and 860 targets we have done so quickly in 4 weeks using this new technology platforms. This is also Buchwald reaction, same like microchemistry platforms. All green color reactions are positive and red color reactions are negative. That's how we do the screening using this methodology. This is again one more example for Suzuki Sunakashira coupling reaction using the same methodology we followed and completed so quickly in 3 weeks time. This is also another example, acid amine coupling using this kind of new technology platform to complete it so quickly. And this also same. Yeah, you can skip this one. These are all, I think, the kind of monomers we have in-house at ROG to do these libraries and all. Next one. Yeah, this is another very interesting technology we have at ROG, and we also started very recently. I think MSc Organic Chemistry people understand it very easily. To assign the absolute configuration of any new molecule, chiral molecule, you know, right, the racemate. Racemate is a mixture of two enantiomer which are R and isomer 50-50%. So when you separate the enantiomers, the racemate mixture into pure enantiomers, we get two isomers, chiral pure isomers, R isomer and S isomer. So when R isomer, S isomer, if the known molecule we take it, we know the absolute stereochemistry, but when we make a new molecule, we don't know the absolute stereochemistry. So when you want to see the absolute stereochemistry, the classical method which is available as on today is make the single crystal of that molecule and assign the stereochemistry like it is positive, this right side rotation or next, left side or right side rotation. And based on that, we assign the absolute stereochemistry, but making X-ray, single crystal X-ray and assigning the absolute stereochemistry, it takes at least 1 month time, and you need to make several crystals, which are not so easy. This is very tedious job and not so easy, and that's why we launched a new technology where we can assign the absolute configuration using this machine, and this machine can identify the molecule whether it is R isomer or S isomer based on the infrared light, and I am going to show that kind of machine. And now we don't need to measure single crystal and can assign the stereochemistry so quickly using this methodology. And this is approved by FDA also and Food and Drug Administration. So that means when we order to make a new medicine or new tablet which is having chiral center, and we can use this technology to find the absolute stereochemistry. Yeah, please. And it's all through infrared light, IR technology. IR spectrum, based on that, this rotation will be measured, and we are now using this machine to find a new, whether R or S for new molecules. Next slide, please. So this is all based on the chiral circular dichroism method. I mean, just making the molecule infrared region, and it makes the circular dichroism type curves, and based on that, we measure the stereochemistry. Next one, please. And this is the machine. So it just looks like simple IR, and we put the molecule inside that machine, sample, and then it passes IR light, and then that IR light, how much it absorbs the molecule, and rest of the light will be emitted, and the percentage of the absorption will be measured, and based on that, the circular dichroism spectrum will be generated, and based on that, we measure the absolute stereochemistry of that molecule. Next one, please. This is the complete set, and this machine will be connected to the computer, and with the computer, we do the calculations for assigning the stereochemistry. This is the formula, left hand side and right hand side. Light will be absorbed, how much light it is absorbed, and the rest will be measured using the this computer technology, and then the spectrum will be generated like this. And this is the light passing through the cell, and how much initially it passed and how much it absorbed, the total will be calculated. The next, please. Next, please. Yeah, this is the picture for the entire measurement. So IR instrument, and then light will be passed. The light absorption will be measured through detector, and from the detector it goes to VCD, I mean vibrational circular dichroism through IR method, and then the spectrum will be generated based on this sequence. So this is the cell and how we make the sample and everything in DMSO stock solution or chloroform, whatever it is. So you will see the case studies and understand how easy it is now to assign the absolute stereochemistry of the molecule. Yeah, this is one molecule where we had S isomer. So for the S isomer, you can see the blue color which is generated through the machine, and also through the calculations the peaks are matching, and then it is assigned as S isomer for this unknown molecule. And similarly, R and S isomer, two isomers we took it. For the two isomers, we assigned as the first one is R isomer and the next one is S isomer. Similarly, these two also we took it, and first is R, second is S. Yeah, next please. This also similarly sulfonamide molecules. We assigned the stereochemistry using the same technology. So that's all. Whatever within the limited time, I wanted to show the new technology platforms which are available at pharmaceutical industry right now we are using, and to produce more number of molecules more easily with less human power, using a more technology, more number of machines, and also advanced technology where to assign the absolute stereochemistry of chiral molecule without measuring X-ray crystallography. We can now assign the stereochemistry of unknown molecule using this BCD spectrum. So these are all very, very advanced technology at pharmaceutical industry, and we are using right now. I just wanted to bring it to you and show it to you. Probably tomorrow, if you join any company, you are going to use this technology platform and run the pharmaceutical industry and finding a new molecule, new medicine. Thank you very much, and if there are any questions, I'm happy to answer you. Thank you.
Any more questions? We don't have time, only one or two questions. Yeah.
Yes, please.
Very nice presentation, sir, actually. So very recent technology of determining the R composition, S composition. Very interesting, that instrument actually. So my doubt is, okay. So usually like we have a cyclodichroism, we have a UV light we use, we have a LCP and RCP, like polarized carbon. But here, what is vibrational cyclodichroism? How it is different? I think is if you have two chiral centers in your molecule, can we able to determine?
Yeah, very good question. So this machine doesn't work on UV light. This machine works on infrared light, IR region. So I told you, right, when we make the compound dissolved in the solution, we put in the cell, and this cell we pass it to the machine, and IR light will be passed, infrared light. And how much the compound absorbs infrared light and how much it emits, the difference will be measured through the detector, and from the detector it goes to the VCD, and the VCD makes the spectrum based on the absorption capacity, and then from that spectrum, first, whether left-handed or right-handed, which one makes the that polarization, based on that spectrum will be generated. So from that one, from the spectrum generated IR, and also we do calculations based on the conformers of the molecule, and based on that most stable conformer, they assign that this is left-handed and this is right-handed. That's why I have shown you one curve is generated, the thick one is generated through the VCD, and the dotted one is generated through the calculations. So the both should be matched, at least neither matching should be there, and then it is assigned as a R or S. And the next question, I think the next question you asked about.
If you have two chiral centers like
Yeah. So if we have two chiral centers, generally 4 isomers will come. 2 power n, right? Yes, 2 power 2. The 4 isomers we can separate through the SFC machine, superfluid chromatography we have. So from that one, first we separate 2 diastereomers, and then from the 2 diastereomers we separate again 2 isomers. The total 4 isomers we separated. From the 4 isomers after separation, we can find the absolute stereochemistry after passing with this machine. At least 4 we can do it, not right now, but more than 4 it is difficult.
Thanks. Thank you very much, sir.
Okay, thank you. And you please go ahead to give your talk now. Oh, 1 minute. We don't get your voice. Okay. Now it's okay.
So, is my voice clear?
Yes, it is.
Okay. Thanks for covering chair, Professor Covers invitation. It is an honor to speak here today, and I'm pleased to present one of our team's achievements. The title is Characteristics of Chemical and Carboatopic Compositions of PM2.5 from northern and southern forests in China. The presentation will be split into 4 parts. First, we see background. Around the world, PM2.5 pollution hits developing countries. It's very hard. It doesn't just make the air dirty. It is a real health danger too. Linked to stuff like heart disease, lung problem, and even cancer. For instance, breathing in this fine stuff is the major cause of millions of deaths globally each year. Plus, PM2.5 messes with our climate system by affecting how clouds form and trapping heat. That's why tackling this pollution is so crucial. Not only for cleaner air and healthier people today, but also for protecting our planet's future. Many places are trying to fight it by cutting emissions from factories, vehicles, and burning fuels, and switching to cleaner energy sources. PM2.5 consists mainly of water soluble in organic ions, such as sulfate, nitrate, and ammonia. Carbonaceous components including organic carbon and elemental carbon, and trace elements like heavy metal. Among these, organic aerosols account for 30% to 50% of PM2.5, making it a core component due to its significant role in atmospheric processes and health effects. It originates from both primary sources, such as direct emissions from fossil fuel combustion and biomass burning, and secondary sources formed through photochemical reactions of volatile organic compounds in the atmosphere. Recent research on the sources, transformation, and impact of PM2.5 has been extensively conducted worldwide. Utilizing advanced analytical techniques to identify regional characteristics and trends. Therefore, comprehensive chemical composition studies of PM2.5 from different regions remain important for understanding pollution mechanism, informing policy decision, and mitigating environmental and public health risks. Forest aerosols display a higher level of compositional complexity than those in urban settings, primarily because natural sources contribute more substantially to their makeup. The secondary formation and aging processes of these aerosols add further intricacy to their chemical and physical characteristics. Forest function as a key producer of biogenic volatile organic compounds, including substances like aspartate and monatides, which act as vital precursors for PM2.5. These VOCs undergo photochemical reactions to generate biogenic secondary organic aerosols, thereby increasing the total aerosol burden. Elements such as seasonal shift, diversity in planet species, and weather patterns also affect emissions level and the resulting aerosol development. Consequently, comprehensive study on the characterization, origins, and transformation routes of forest aerosols are critical for assessing their effect on the environment and the climate. Here is the methodology. We selected two typical forest ecosystems in China. One is in the northern Tangbai Mountain, another is in the southern part, Xishuangbanna. The temple forest is referred to the Changbai Mountain, and the tropical rainforest of Xishuangbanna, representing different vegetable types and climate zones in China. We conducted comprehensive chemical and stable isotope analysis of PM2.5 at this site. From 2023 to 2024, we collected PM2.5 samples at both Changbaishan and Xishuangbanna sites, and performed chemical and isotopic analysis of water-soluble ions, organic carbon, elemental carbon, water-soluble organic carbon, and stable carbon isotopes. This comprehensive approach allowed us to characterize the composition profile of particle matter and investigate its potential sources and environmental impact in the region. The result shows that it except for sodium ions and potassium ions, concentrations of most ions were generally higher at the Changbaishan Mountain than at the Xishuangbanna site. This difference may be due to varying local sources such as industrial emissions or traffic-related pollution at the Changbaishan location, whereas the Xishuangbanna site might represent a background area with lower anthropogenic influences. The three major secondary ions, sulfate, nitrate, and ammonium, make up 86% of the total ion mass at Changbaishan and 76% at Xishuangbanna. Meaning secondary inorganic aerosols make up most of the particles at both sites. These aerosols are formed through chemical reactions in the atmosphere from precursor gases like sulfur dioxide, nitrogen oxide. Therefore, that is the significant role of human activities in the particle matter formation. Additionally, the higher percentage at Changbaishan indicates a greater impact of secondary processes there, potentially leading to higher pollution levels or meteorological factors that favor aerosol formation. It's worth noting that all nitrogen compounds like water-soluble total nitrogen, inorganic nitrogen, and water-soluble organic nitrogen had much higher level in winter, likely due to seasonal factors such as increased biomass burning and reduced precipitation that concentrate this pollutants. This matches what was seen in the tropical forest from Brazil during heavy burning time, where elevated nitrogen compounds were documented, primarily driven by deforestation and agricultural fires. The consistency across this contest strongly suggests that fire activities might play a big role in releasing nitrogen-based compounds into the atmosphere, potentially impacting air quality and ecosystem health. In terms of carbonaceous components, organic carbon concentration was constantly higher than elemental carbon concentration, and organic carbon, water-soluble organic carbon, and secondary organic carbon all showed thinner pattern with higher levels in winter than in summer. The stable carbon isotope revealed that values were generally more positive at Changbai Shan and more negative at Xishuangbanna. The summer carbon isotope values were significantly lower than winter values, primarily due to the vigorous metabolism of C3 planets under high temperature and high humidity summer conditions, which release more carbon-12 enriched organic matter. Meanwhile, non-sea salt, potassium, or biomarker for biomass body showed a significant positive correlation with sulfide, nitrate, and ammonium, further supporting the influence of biomass burning in summer. Additionally, a strong correlation was observed between water-soluble organic carbon and organic carbon. The R value is more than 0.75, indicating that they share highly consistent sources, likely jointly influenced by biogenic emissions and combustion processes. We also found that the ratio of water-soluble organic carbon and organic carbon at both sites was similar to those previously reported for urban biomass burning sites, suggesting significant influence from combustion sources, particularly in winter at Changbai Mountain. The ratio, the SOC to organic carbon ratio increased significantly. Combined with the local practice of burning wood for heating, we believe that biomass burning effectively promotes the formation of secondary aerosols. Also, the fossil fuel combustions. More importantly, the carbon isotopes evidence showed that winter values were more positive, especially at Changbai Mountain, with concurrent increases in sulfate and nitrate concentration, strongly pointing to fossil fuel combustion as an important contributor in winter. But however, in summary, although both sites were located in forested background areas, they are still affected by anthropogenic activities, particularly combustion emissions from winter heating. Here's what we found in this study. In conclusion, first, carbon and nitrogen stuff was higher in winter than summer, and the secondary organic carbon and the water-soluble organic carbon were higher during the day than at night. At Changbaishan, sulfide, nitrate, and ammonium, these ions were the big layers, while at Xishuangbanna, the southern forest, sulfide, ammonium, and potassium took the lead. The carbon isotopes compositions of total carbon values were between minus 27.8 per mil and minus 22.1 per mil at Changbaishan, and from minus 27.6 per mil to minus 24.5 per mil at Xishuangbanna. They are very familiar. The fourth, K aerosol doses are natural emissions by mass burning, and the land-based stuff with fossil fuel burning matters more at Changbaishan, the northern forest, in winter. This study concluded that the chemical and isotopic characteristics of PM2.5 sources within forested regions in China is establishing a scientific foundation for the formulation of regional air quality management policies. Thank you very much for your kind attention. Thank you.
Okay, thank you, Dr. Gandhi, for sharing your research and giving a good report on the forest aerosols impact on the health and climate, as well as the potential sources of aerosols in different regions of China and how they will be measured. Thank you very much for your talk. Now we will take one or two questions if there are any to ask. Anyone has any question? If you want, one or two.
One more question.
Okay. Seems no. Okay, thank you very much. It's done. Janji, Dr. Janji, can you hear me?
Yes, I can hear.
Okay. Thank you for your talk.
Okay, thank you.
Next, we have another talk from B. Vijay from West Pharma, and I would like to request Renu Sri to introduce the Vijay Sardigar.
Good afternoon, everyone, respected dignitaries, and my dear friends. I am Renu Sri, pursuing second MSc Analytical Chemistry. It is my privilege to introduce Mr. B. Vijay Sardi, sir. Mr. Vijay Sardi holds a master's degree in chemistry, along with industrial safety engineering and business administration, with an outstanding career spanning over 25 years. He has led the domains of safety, health, environment, and sustainability in top Indian corporates such as multinational organizations. He is currently serving as an head of HSE at West Pharma, Sri City, where he plays a key role in implementing global safety standards and driving sustainable operations. He served as the lead for the PSCI India, an international initiative formed by major pharmaceutical companies to ensure higher standards in human rights, ethics, environmental responsibility, occupational safety across the supply chain. He is a lead assessor for the CII in the areas of safety, health, environment, and sustainability, and a lead auditor for ISO 14001 and ISO 45001. Beyond his corporate achievements, he has delivered lectures and presented papers at prestigious platforms such as IIT Mumbai. He has authored thought-provoking articles on topics such as big dams, the Kaveri River water dispute. We are truly privileged to have you here, sir. Thank you for gracing this occasion with your presence. Thank you for giving me this opportunity.
Okay, this is the record. This is yours.
So good evening all. It's not the right time to speak because generally afternoon sessions are very difficult. That too after 4 o'clock is still difficult. Still I am seeing some people leaving. Okay. So it is not their fault. Okay. Let it be. So today I am not going to talk about, let's talk about chemistry. No. I'm not going to talk about chemistry. Okay. And I'm not going to talk about China. I'm going to talk about India. Okay. The topic is that the evolving threat of antimicrobial resistance. Next. So these are the topics which I'm going to cover. Next. Next. Oh. Go back. I thought that I'll go with some kind of questions. Already has given the answers. Okay, no use. So go back to the previous. Yeah. What are some important discoveries of human beings? Already it is there. I thought that I will ask this question to you, but unfortunately you know the answers. Thing is that control of fire, weed, agriculture, land. Control of fire is the first time when the human beings started to control the fire. Then he started to destroy the nature. So by controlling the fire, okay, he cannot go and fight with other wild animals, okay, to get the food. Then he thought that he can lead the forest, okay, so that all the animals will be get dead. Then he can take the food. Like that, okay, we started our civilization in such a way that by destroying the nature. Correct or not? Yes. Then wheel. After wheel only there is a lot of industrial revolution. Agriculture and all those things are because of wheel. Then agriculture. We started to destroy forest and domesticate animals and also do the agriculture for our purpose. Finally, language. Language which we could be able to transfer our knowledge and transfer our greediness, transfer our thoughts, everything to our next generation. Now, next question is that oldest living beings in the world. This is another question which I thought I will ask you, but as usual the answer is here. Microbes. So why I am talking about microbes is that this is the oldest living beings and it has existed in here 4 billion years ago. And still here you can have thousands of billions of microbes will be there, and even in your body also millions of microbes will be there. Now the question is that what is the role of these microbes? The microbes plays a very important role in sustaining the life, particularly for human beings, like digestion of food, then reproduction, then everything, then agriculture, that enrichment of soil, everything. Okay. So all microbes are useful to us? No. 1% of microbes, like bacteria and all those things, which are not useful, okay, they will create infections, they will create diseases. Okay. So before these medicines are there, human beings used to suffer a lot when they don't have any kind of answer to all these infections from these microbes or from these bacteria. So at that time, we used to suffer and there will be a lot of deaths will be there. What is the important discovery in 20th century? Any idea? Important discovery in 20th century. The important discovery is next. Yeah, good. Give me a big clap. Antibiotics. Next. Next. So the important discovery of the 20th century is that antibiotics. Yeah, next. So antibiotics is the most important discovery. So because of this antibiotics, we could be able to treat the infections. Okay? We could be able to survive against these the bacteria which cause infection in our body. First one is that, which is discovered is that in 1909 by Paul Ehrlich, that is the antibiotic is sulfuracid. Then after that we got penicillin, streptomycin, vancomycin, everything. Okay. This discoveries has saved millions of lives for the last 70 years. These microbes, what they will do is that they will go and kill the bacteria, or they will inhibit the growth of the bacteria, or they will make the bacteria to get inactivated. By doing this one, they are surviving from infections. Next. So among the antimicrobials, antibiotics are very, very essential. Because of these antibiotics, we are protected from a lot of infection diseases. In modern medicine, particularly when you go for surgery and also kind of cancer treatment, if you don't have these antibiotics, then you could have resulted in a serious complications, including death. Because of these antibiotics, the infections are reduced by almost 80%. So 80% the infections are protected by these antibiotics from the microorganism, that is particularly the parasites. So currently antibiotics help us to lower post-operation infection rates to below 2%. These antimicrobials, as I said, they will inhibit or kill microorganisms and prevent the infection diseases. Then man used to think, it is useful to us. Why not we use it for other areas? Then he started to use these antibiotics in where? Agriculture, aquaculture, and also in the food industry, as well as in the livestock, for animals, everywhere these antibiotics we started to use to get benefit, to have a comfortable life. Next. So these are the areas which we are using the antibiotics. They are used for therapy, control of diseases, as well as disease prevention, as well as for growth promotion. So we are happily using the antibiotics. Correct? Not only for us, for everything. Yeah. Even when we go to some, during COVID, we used to have this, disinfectant to suppress the killing of these microbes. So these are also where we used to use this antibiotics. Next. So we humans are in total control what is happening around us. Agree or not? We have everything, correct? No? How many of you are saying yes? How many of you are saying no? So nobody. We are in total control, correct? We are all living a very happy life, Everything is below us. Correct? Correct or not? No. I see many hands nodding yes. Somebody saying no. But, yeah. Next. So we have everything. We have everything from satellites, from AI, from Boeings, bullet trains, including nuclear weapons. Maybe human beings are the beautiful creatures in the earth, where, yes, out of his sheer knowledge and greediness, he has developed, he has discovered a weapon to destroy himself. No other living thing the nature would have done that. So human beings are the only living things who has invented or discovered a nuclear weapon to destroy themselves. Whatever nuclear weapons which we are having today can destroy this earth 6 times. so that there will not be any. In 1960 there is a big, almost we are supposed to have a kind of nuclear war between USA and America. If that war had happened, okay, today we will not be here. Almost they positioned the missiles, everything, but they didn't place. Finally, okay, they stopped. So that is beauty of us. Next. Tell me some man-made disasters. Next. So, from Ebola to COVID, to intolerance, to wars, riots, inequality, misuse of chemicals. Correct? These are all applicable to us, correct? Intolerant. We are not tolerant. We are intolerant. We are intolerant. That's why we are greedy. That's why we have wars. Now there is a wars between Russia and Ukraine. There will be wars between other countries also. There will be riots also because of what? Intolerance towards other religions or other castes. Something like that. And inequality. Where we will not treat everybody equally. Okay? That is the kind of disaster, okay, we have made. Finally, misuse of chemicals in our daily life. Next. Next. So one such disaster, how many of you are reading newspapers? How many of you are reading newspapers? Nobody in this? Nobody's in the newspaper? Huh? Okay. So these are some of the clippings, okay, if you have gone through the newspapers daily, which we are not seeing daily, morning wake up, we will go to our mobile, see the WhatsApp. Then, whatever the messages, okay, which is forwarded by your friend, his friend, finally you got that, you will see, and you will forward it to someone else. Okay, my responsibility is over to the society. I had done a good thing. Then, go to Facebook. See the friends, somebody from China, Jihu. If he sends a request, accept. Like that. Then, we'll see our post. How many people have given like? Oh, 10 people. Who are all people? Oh, that girl is still not giving. That boy is not giving. Okay? Some people will call them and tell why you are not giving me the like. Correct? So we are very busy in the morning, okay, with our phones. Still some people in this auto will also using phones. Correct? Knowingly or unknowingly. So that's kind of addiction we have towards the mobiles. So these are the some of the clippings. Okay? At least now onwards, okay, please morning or afternoon take the newspapers, see just at least some kind of news, okay, which will have kind of impact on us. Otherwise, okay, we will go to stage where, okay, nobody knows about us, and we are pushed to such a corner that it's very difficult to come back. So these are the some of the headlines. Okay? This talks about antimicrobial resistance. Hello, excuse me. Last. Please, thank you. Good. Okay. Next. So, antimicrobial. What is this antimicrobial resistance? Okay, we have heard before. So previously, okay, you ask your father when he got cough, how much time it will be there? Maybe 4 days, 3 days, 5 days. Now the same cough, after 20 years, if you are getting cough, it is lasting for 10 to 15 days. It is lasting for 10 to 15 days. There is any change in the country? Any change in the environment? No change in the place, correct? Same only, but there are lot of changes in our environment. So, this is because of the microbes are becoming resistant to the drugs which we are using. The microbes are getting resistant to the medicines we are using. The microbes has its own survival mechanism, which they have developed, okay? And through millions of years. Because they existed 4 billion years ago, correct? So they have their own mechanism. Now we have 1950, somebody has discovered an antibiotic and to kill them. Will they become quiet? Will they be quiet? No. Because there are a lot of living things in our world where they become extinct, like dinosaurs, which we are seeing only in movies. But these microbes have survived 4 billion years, just imagine. So they have their own survival mechanisms. So the bacteria and all those things, where they are natural part of evolution, these microorganisms adapt and survive through the genetic mutation and also through the selection pressure and through the transfer of gene from one bacteria to another. Let's see how it will happen. If you see here, no slider, okay. If you see here, any antibiotic which we are giving to the body, there will be a lot of microbes will be there. This antibiotic will go and kill that what? That bacteria. And it is not only killing that bacteria, it is also killing the other bacteria also. So all bacteria will not die. There will be some bacteria which will become resistant. For example, in this audience, if somebody comes with a gun, what you will do? Everybody will find the way, correct? To run away. And 1 or 2 people will be there. They will fight against. Correct or not? Who are those heroes? Anybody? Nobody. So nobody in this university cannot fight. Somebody has raised a hand in the last. Oh, good. There is only one hero is there. Please stand up. Please. It's time to become hero, correct? Yeah, come on, fight. Yeah, give a big clap. See, everybody seeing you, okay? So like that, this bacteria also, there will be some heroes will be there, they will become resistant against these drugs. What they will do is that, next, what they will do, whatever, okay, the resistance they acquired, they will transfer to other bacteria. Then, over a period of time, what will happen? The bacteria which are in minority are becoming, okay, majority. When they become majority, at the time, when you give any drugs, okay, the drugs become resistant. This is a kind of natural process. Not only that, these bacteria will get the gene, nuclear material from the environment also to get survived. That's why they are surviving for 4 billion years. And also, once they get that gene, they will transfer that gene to the cells so that the next generation will become resistant. After that, through the kind of mating also, they will transfer the gene. So like this, the bacteria are becoming resistant to the drugs which we are using nowadays. Next. So antimicrobial drugs are best weapons. 10 minutes? 15 minutes? For that. So these antimicrobial drugs are best weapons against the pathogens. So these seeds of inactivation, each time they are deployed. So we are in a situation where the antimicrobial drugs can cause the emergence and spread of antimicrobial resistance in our body, which is happening now also. Next. So these antimicrobial microbials which are resistant, okay, which is protect against the microbials, now they have become the great threat to the mankind because these microbials are resistant to them. As a result, the medicines will become ineffective against the infections. So there is a threat of increasing the illness, deaths because of the antimicrobial resistance. So without effective antibiotics, our lot of treatments, including operation, will become difficult because when you treat, okay, when you do the operation, there will be a lot of infection will be there. If you don't have these infections, the bacteria will do it. If you don't have the antibiotics, what will happen is that these Because of this operation, okay, the chance of infection will be more, and the chance of the person getting died also will be increased. Next. So, antimicrobial resistance is called a silent pandemic, or not like a COVID or hidden disaster. COVID everybody knows because we wear masks. But antimicrobial resistance is not like that. It's a silent. That's why many of you don't know about the antimicrobial resistance. Everybody know about COVID, correct? Now, most of you don't know about the AMR because it is a silent pandemic. Every day it is increasing. Why it is called a hidden disaster is that it is significant mortality, lot of deaths, threat to modern medicine, economic burden, and slow onset versus acute crisis. Next. So, AMR is a global threat. As per the World Health Organization, it is identified as one of the top 3 global threats in the world. So, the widest use of antimicrobials in daily life has led to alarming levels of antimicrobial resistant bacterial infection in the 20th century, which resulted in the bacteria becoming resistant to these drugs. Okay. It can affect, even not only the humans, it also affect the animals also, which lead to food security also. Presently, as per the data, we have 5 million deaths. It's almost 50 lakhs deaths due to AMR. And by 2030, 2050, it will rise to 10 million deaths per year. Which are going to get affected? The countries with low developing countries like India are going to get affected because we have very poor infrastructure. Next. So because of this one, now we have one more problem. Even the pharma industries, who used to develop the antibiotics, has stopped the production of antibiotics, new antibiotics. The reason is that whatever the antibiotics which they are producing are becoming ineffective. There is no antibiotic in the R&D of the pharma industries because to make a new antibiotic, it will cost nearly 8,000 to 13,000 crores of rupees, and it's very difficult. It will take 10 to 15 years. By 10 to 15 years, whatever they are discovering, they are becoming ineffective. So the return of investments to the pharma industries are very, very low. So that's why most of the pharma industries have stopped the research and development in the antibiotics, new antibiotics. So that is also a grave crisis to us. Next. What is the worrying factor for India? 80% of the population in India have a superbug. That is, we are multi-drug resistant organism.
Wireless. See, hand pipe it, sir. Yes, sir.
Okay. Hello? Almost 80% of the population are becoming resistant, are carrying a multi-drug resistant organisms in our body. Just imagine how it is going to impact. Whereas 70% of the population are having these ESBL. These enzymes can break down most of the antibiotics. And nearly 23% have carbaphenum resistant bacteria that will even make ineffective even the last highest effective antibiotic also. This is the situation in India. Another disturbing fact is that for every 1 minute, for 9 minutes, one child is dead because of the antibiotics. Almost 50 million deaths, 58,000 newborn deaths are related to AMR in India. It's a national health disaster. Next. Okay. I will just summarize. If a person with a multi-drug resistant bacteria comes to the hospital, he will get cured in 48 hours or in 2 days. And the cost is something around 70,000. If the person with drug resistant bacteria come to the hospital, it will take 4 to 5 lakhs and it will take 15 days. So we are starting at a future where simple infections may become untreatable. Next. So this is the what is called GDP. Our GDP also will get affected. Almost 3% will get affected because of this antimicrobial resistance. We will be losing something around 10 lakh crores. 1% of GDP is equal to 3 lakh crores. Next. What are the sources of high prevalence of antimicrobial resistance in India? Let us see. Overuse and misuse of antibiotics, anti-antibiotics, lack of qualified medical professionals, fake medical professionals, easy over the counter availability of antibiotics, incomplete treatment courses, widespread self-medication, gaps in surveillances, hospitals and clinics lacking consistent infection control system, APIs in wastewater from pharma industry, and indiscriminate disposal of biodegradable waste. Next. This is the supply chain of antibiotics. Next. Because of time constraint, I'll just run through the slides, okay? Lack of qualified medical professionals. The IC Indian Council of Medical Research has found out that almost 45% of the medical professionals who have very good experience are giving a wrong prescription of medicines. This is not my report, this is the report given by the Indian Council of Medical Research. And one more disturbing report is that 10% of the medical professionals are giving a totally different prescription which is not at all required. So what will happen is that these kind of subtherapeutic dosages or wrong prescriptions will lead to antimicrobial resistance in our body. Next. Sorry. One more thing is that now the government in some states, the Ayurveda, Yona, and these doctors are being are licensed to give the prescriptions of allopathic medicines which they are not at all aware. They don't have knowledge also. Still, they are giving license to give prescriptions. Okay. Next, come to the fake medical professionals or fake medical professionals in India. Another disturbing trend. As per the WHO report, 1/3 of people who are saying that they are medical professionals are not at all studied up to 12th standard also in India. Even if you go to places called in North India, all those things, there will be doctor sitting outside and having a white coat. They will give prescriptions. So 70% of healthcare providers in rural India have no formal medical training also. Rural India. Rural India means villages. Have no formal medical training also. Stories of fake doctors we are hearing. Okay? Somebody in Madhya Pradesh, he has done 7 surgeries, heart surgeries, and killed 7 people. Saying that he is from UK graduate. See the condition. Because in private hospitals, you don't know the doctor is doctor or not. Correct? There is no kind of system to check the track record. We all believe. In many parts of India, where public healthcare system is beyond, is only up to the maternity care and immunization, these informal or fake medical professionals are entering this field. So, what is the punishment for these fake doctors who killed many people? As per the National Medical Council Act, the punishment is that he has to pay how much? 5 lakhs and jail up to 1 year. After that, you can go and practice in somewhere else. Again, you can pay 5 lakhs and survive if you get caught. Next. Other one is that over the counter of sale of antibiotics. Almost our usual practice is that if you are not feeling well, we will go and ask the pharmacist. I am not feeling ready, what to do? Then he will check and give some medicine. Return. Still it is happening. So 63% of over-the-counter sale of medicines are without prescription. It is just given by the pharmacist, whom they don't have any knowledge. Instead of enforcing it, the government is legalizing it by saying that license is not required for the sale of drugs, which is strongly opposed by the AIO3D, that is All India Organization of Chemists and Drugists. This is further diluted. Already we are in a grave situation. This is further diluted by the online sales of drugs, medicines. And finally, Finally, as per this Drugs and Magic Remedies Act, okay, you are not supposed to advertise and say that, okay, this hospital will cure, this medicine will cure like that. You are not supposed to do that advertisement. But still, it does not prevent our Baba Ramdev, Patanjali Guru, in publicly saying that a healthcare medicine can able to protect you against COVID, raking millions of crores of rupees. Okay. Finally, has to apply this. Nobody knows, but still, he made a lot of profit. Because he publicly advertised that, and people believed that, okay, this medicine will work against COVID. This unregulated sale or unprescribed sales of antibiotics to the body will increase AMR in our body with irreversible side effects. Next. Incomplete. Another thing is that incomplete treatment process. Suppose we will take 6 drugs. So 2 drugs we will take. 3. Fine. Then stop. Correct? Or while taking from medicine shop itself, you will not take full drugs, you will take only so 50% only. Like that we will take. So what this will happen is that when we are stopping this killing of this antimicrobials fully, okay, it will become resistant in our body. So why this is happening is that financial constraints, lack of awareness and education, poor insurance program, lack of government medical facilities. So these are the factors which contribute people taking only 50% of the medicines, not 100% medicines. Again, it is creating a AMR in our body. Next. Commercialization health sector. In 1950s, okay, government private health sector is only 7%. Today, it is 70%. The rapid increase of privatization in the healthcare sector is another contributing factor, because these private healthcare hospitals, they do not do the control of infection programs or immunization. They are more about the profits only. How it has happened is that after this 1990 new economic policies, almost number of private hospitals has increased and public hospitals have come down. What has happened is that because of this one, India is one of the highest countries. We are one of the highest people in the world to spend from our packet. Highest. Almost 65% of the people are spending from our packet, which is not so in other countries. We are one of the highest. Because of the public infrastructure cut by the government. Next. Medical education. So we all know about, okay, medical education is, okay, only 50,000 seats are there. Remaining all private hospitals, private doctors, where you have to pay nearly 1 crore rupees. When a person who paid 1 crore rupees, okay, can you go and do the service to the common people? No. And this, okay, kind of system also creating a lot of controversies. Even that the entrance system is creating a lot of controversies. And this is another area where, okay, the government should look into it. Where we need more government colleges than the private colleges. But what is happening is that reverse. A institute is started only 4 years back, is getting additional 100 seats. The government college, which is there for 50 years, the same seats are there. So you cannot expect these people who have invested nearly 1.5 crore to go and do the service, correct? So what they will do is that they want the return of investment. Even if they are good, if their parents or banks will ask that, okay, you spend almost 1.5 crore, where is the return of investment? So they will go and get the paid in good hospitals in the urban sector, where they have targets in the private hospitals, all those things. So it is also creating a lot of air. Next. Even public health expenditure also is only 1.6% of our GDP. That is gross domestic product. If you take the developing countries, 5 minutes. If you take the developing countries, it is 10%. If you take the developing countries, it is 5.1%. Next, India is the last. Back. Okay, next. So, next. Substandard and banned drugs still available. They are repacked, and banning of drugs in India is a big process, and it's a lengthy process. There are a lot of banned drugs are available in the market. Next. Why banned drugs are available is the pure infrastructure and a lot of lengthy process. Next. So it doesn't mean that whatever we said, that doesn't mean that we don't have good medical professionals. We do have good medical professionals, because that's why our health industry is globally. But there is these people only for the rich people or for the people from outside. Next. So again we are using antibiotics in livestock. Next. Most of these antibiotics which we are using livestock, like animals and all those things, are more than the maximum permissible limits. It is crossing. Next. APIs in the waste from the pharma industries. Even though we are the third largest producer of the active pharmaceutical industries, or pharma industries, there is no standards for the active pharmaceutical ingredients in the environment. There is no standards. Next. Improper disposal of medical waste. Water waste generated from hospitals, it should be disposed properly. Next. Next. So overuse of antibiotics in agriculture also. Next. Antibiotics in preservatives and disinfectant including food. Next. So we think that okay, we do have common remedy called legal system, but unfortunately our legal system is such that as of late 2020 we have 5 crore cases pending in the courts. 5 crore cases. After that 70% prisoners are in jails as under touch without any conviction. Most of the people who are convicted are get paid. And why I am saying is that even though we have remedy, but still our judicial system is very lengthy. We are not getting any kind of remedies for them. Next. So what is our approach? Our approach should be one health approach. It is not only human beings. We should take care of environment. We should take care of animals. We should take care of ourselves. Next. How is that? We should raise awareness on the antimicrobial. After going to your home, you can think and talk to your parents, talk to your nearby, saying that these are the factors which are creating antibiotics, antimicrobial resistance in our body. We should be careful. Next. Be responsible. Never take antibiotics without your doctor's prescription. Avoid self-medication. Don't demand antibiotics for small cold and all those things. Always complete full antibiotic course. Maintain strong hygiene habits. Keep vaccinations. Handle pets and livestock with care. Prefer organic food. Create awareness to the people. Without immediate intervention by the public and government, India risks entering a post-antibiotic where common infections, routine surgeries, and everyday medical goals will just become life-threatening. The study they conclude is that it's a wake-up call for all of us. It's time to stand up and do some kind of brainstorming to stop this disaster. Otherwise, we will be responsible for our actions. With this, sorry, we don't have time to stand. Okay. Thanks all for your patient listening. Okay, you that is all.
Okay, thank you, Vijay Sardi, for your enlightening talk about antimicrobial resistance and how the overusage of antibiotics influencing the health. Thank you.
Last.
Thank you.
Thanks all. Okay.
Okay. Now we have tea break. Generally, tea break should be at least 15 minutes, but I request you to take your tea, collect your tea, and come back to the hall. Now we are going to have oral presentations here. First, we have 2 presentations from Geetham University and 2 or 3 more presentations from other research scholars. We will mostly take 6 to 7 presentations today. Who are leaving today itself, you please come here and give your presentation, share with the technical staff here. Then we can have the oral talks. Remaining all scholars and faculty members, I request you to refrain to present today. Tomorrow morning and afternoon you can give your oral talks. If the number is too high, we will arrange the 2 parallel sessions. Otherwise, we will conduct all oral talks here itself. And I request all the 5 presenters first share your PPT with the technical staff. And after 5 minutes, it means 4:35, we will start the oral talks. Thank you.
Hello, excuse me. Thank you. Oh, great.
And hello all. And one more announcement is, as I have communicated to you all over email, the poster sessions will be continued from 5 to 6 o'clock. So all poster presenters, I request you to stand beside your poster to explain to the delegates who are visit your poster. Thank you.
तुम्हारा भी कर दूँ